Hi, my name is Sarah Wilson, and welcome to this proof using the segment addition postulate. You can see in the diagram there that we have some segments that are all end-to-end, and we've been given that segment AB is congruent to segment CD, and we're trying to prove that segment AC is congruent to segment BD. So let's start this proof off the way that you start every proof. That is with the givens. So segment AB is congruent to segment CD. And of course the reason is given. And before I go on to any more steps, I'm going to go up to the diagram and mark those segments congruent. So there it is, the little purple marks show that AB is congruent to CD. Now in the next step, we're going to be doing some addition in this proof, and so I don't want to work with the segments themselves, those are the shapes. To do addition, I really want to talk about distances. And so I'm going to change this statement to say that the distance from A to B equals the distance from C to D. And the reason I can do that is the definition of congruent. That's what it means for two segments to be congruent, is that they have the same distance. Now the next step is BC equals BC, which seems pretty obvious. The reason for that is the reflexive property. Now you might be thinking, okay, why do I want to use that? We're going to be using BC and adding it on to both sides of the equation up above, and so it's almost like we're making a copy of BC right now using the reflexive property. Anytime you have something shared between two parts of a diagram, then you use the reflexive property. So let's go ahead and mark that in the diagram. There it is. BC is congruent to itself. Now it's time to take that line above, the one that says AB equals CD, and let's add BC to both sides of it. So you can see right here, there's the BC being added both to the left and the right. And what is it that says we can add the same thing to both sides of an equation? Well, that is the addition property of equality. Now, let's take a look up in the diagram of what we have now. We've got AB plus BC, and I'll mark that. There's AB plus BC. That's that whole distance there. And BC plus CD, and there that is, BC plus CD. And you can see the segments now, the large segments that we're shooting for are overlapping each other a little bit. Now let's go ahead down the next line and write the two small segments, each on the left side and the right side, as one larger one. So AB plus BC can be written as AC, and BC plus CD can be written as BD. And that is the segment addition postulate. It lets you rewrite two small segments as one large one. Now the last thing here, I'm trying to prove that segment AC is congruent to segment BD. And we're pretty close right now, but notice that it's still in distance notation right now, and I want segment notation. So just like before, to flip back and forth between those two kinds of notation, we just change it back to the segment AC is congruent to segment BD because of the definition of congruent. And there's our proof, all completed, showing that those two segments are congruent to each other using the segment addition postulate. Thank you for your time. I hope this has been useful to you. If you have any questions, please don't hesitate to contact me at the email address down below.